Okay, guys, welcome to my talk. It's a journey into cloud modeling on AWS. Just so you know, I am a founder of a company called Cloud Choreo. We were purchased by VMware in February, and kind of what we did and do is security in the cloud. We kind of figure out what you're doing, and we have kind of a novel way to do it. I'm going to kind of bring you through the back end right now, and I don't know why my co-founder's name is on there, but he's not here. I'm Paul Allen. Also, since there's not very many people, please feel free to interrupt, ask questions, whatever you want. It is a code session. I'm the not only the founder, but also CTO. I designed the whole thing. I can go as deep as you want to go. So I'll get into it. So here's the marketing slides. I'll skip through them a little bit, but basically you can get started with cloud.vmware.com. Our product is now called Secure State, and yeah, it's pretty easy to get up and going. Again, more marketing slides. What do we do? Deep insights. I'll show you a little bit more about that. That's kind of what I'm going to focus on. And our architecture is designed to deliver information to you in nearly real time. If you have a vulnerability in your cloud, we can detect it and alert you, Slack, email, whatever, in under 10 seconds, which is kind of new to the industry. And everything else you would expect, reporting, et cetera, et cetera. More marketing slides. Sorry. Yeah, so skipping it. All right, so how are we different? So the majority, or I guess the biggest difference of us and everybody else is that we had decided somewhere along the line that we were not sort of succeeding in this security space inside of cloud. And the reason I say that is everybody else in the industry will go through and check everything you're doing one object at a time, tell you what you're doing wrong, great, but there's no context. You couldn't understand, as a security guy, you couldn't understand what those objects were doing, what they were part of, an application, a team, whatever it was. And what we decided was we had to do better. We didn't care about the object. We cared about how the object existed inside your infrastructure. We cared about the configuration of each object, and if that configuration leading to the next connected object, if that caused a vulnerability. And that kind of screamed, in case you couldn't tell, graph database to us. So traversals, right? The idea with a graph database is that you can define conditions based on a node, an object, and its connection to another object. We don't care about those objects, we care about the path through them. So in this example, right, like given these conditions, given that, so I didn't actually create the slide, one of my guys did, and he wanted to make it really complicated. So anyway, this does work, but given that the label of an edge is mod 7 equal to the sum of the labels of all the nodes in the path mod 3. What does that mean? It's a bunch of math. The idea here is that you can start in a spot, perform any sort of calculations around on an edge, these lines, and as well as the properties on the node themselves, so like 0, 5, 4. You can perform operations on these and allow the graph database to answer the question, what nodes does that lead to? Right? You can have all of these various connections, all these various conditions, and then calculate the actual path through the entirety of the graph. So that's a lot. I said a lot. Maybe it wasn't that clear, but I'll apply it to the real world. So inside of Amazon, this is actually a picture of what our data model looks like in the back end for a very small subset of a cloud. The idea here is if I want to know a server that's open to the public, if it has administrative access, or even better, if a server that's not open to the public shares an SSH key with a server that is open to the public, how can I even find that, right? In classic AWS modeling, in classic just clicking around, getting your API calls, you can't really tell what's going on with that. But when you start adding these things into a graph model, you can. And so that's kind of what we have here. Actually, hold on one second. Sorry. Yeah, sorry. Yeah, so that's kind of what we have here. This is the exact scenario I told you about, and this is actually one of the violations that we check against inside of our system. What you have is the definition of a public server, and the way we define it is by saying, okay, if you have an internet gateway, I'm sorry if I'm talking outside of your comfort zone within Amazon, but if you have an internet gateway with a route table that's associated to a subnet, and you have servers inside that subnet, chances are you're public to the world. Okay, that's one definition. If I come from the other side and I say, okay, if I know what an administrator policy looks like, and I've got that attached to a role that's attached to an instance, this is administrator instance right here. What you notice, and what any other system would notice, is that this instance is not public. It's totally private, unaddressable. Nobody can get to it. Awesome. This one is totally public, or these three, I should say, are public. And what our system has discovered is that it's sharing an SSH key. So you can actually get lateral movement. Should this SSH key be compromised, any attacker can sign into these public servers that have no access at all and SSH over into your admin server. So that's kind of what Secure State does at the deep level. We model your entire Amazon and Azure architectures inside a graph database, and then let you subscribe to queries. So if you figure out something that might be an attack vector, you can actually subscribe that query, and we'll alert you within 10 seconds if it ever pops up inside your infrastructure. This is a code talk, though. So let's get into the code. The cloud providers realized a long time ago that they couldn't keep up with themselves. And we've been able to capitalize on this idea because what they do now is they define all of their APIs with basically documents. And then they automatically generate their SDKs. That's just how it works now. What we are able to do in the back end is reverse the process. So we can actually discover all API calls that are allowed to be made within any cloud, and we can go out and actually do that discovery for your initial setup. So that kind of gets us the inventory, so to speak, and then you can hook up your cloud streams, your cloud exhaust, I call it, and just throw the fire hose at us, and we'll keep your model up to date. But what's cool about that is that when one little change comes in for any of your objects, it gets inserted into the graph as a whole, and then we can instantly check the graph for these violations rather than going back to your API calls. So we don't care about the API calls. We trust our model to be correct all the time. So with Cloud Choreo, Secure State, we've separated the data layer out into this thing we call Rosetta, and that's kind of where I live and breathe in my day-to-day. And what it is a generalized data store for anybody who cares about connected objects. And it's kind of hard to say and harder to explain, but the idea is that you can, if you have a model, in this case Amazon, AWS Cloud, if you have a model that you know, you can actually create your own plugin for our Rosetta system. And that will let you insert all of your objects that you discover into the graph database, and Rosetta will put them in the right place and make all the connections that need to happen. So I'm going to talk about that a little bit. This is a JSON representation of a discovery for VMC. So what you can see is we care about very few things. We have a concept of a central node, and you can think about that as your first API call you make. In Amazon, it might be list buckets. Okay, when you do a list, does everybody know S3? Okay, so in S3, the root directory is called a bucket. That's basically a big file store. So if I say list buckets, I'm going to call that my root. Each bucket is a root node. The crazy thing is that once you have a bucket, you can make 100 other API calls to discover more information about that. And each one of those API calls for us becomes its own node. And so we insert those under connections. So it's a new object. And so Rosetta, in the back end, will understand that that is a child relationship, even though there's no parent-child, but it'll actually make that connection for you so you can search it later. So we require you fill out a few things: label, object ID, and location. Those are totally arbitrary. Whatever you want to do, it's to keep your data separate. And then all your properties. You got to tell us what type of property it is and the value, and you're good. So as you start going through all that, you end up slowly building a model. So one object at a time you can do. If it has children or relationships at all, you kind of build it up, send us your JSON blob, and we insert it. So you end up kind of with this this traversable graph now, where you can actually point and click around. We'll show you all your data. You can do all these things. You can discover, but more importantly, you can subscribe to queries. So if you know a vulnerability, you can tell us, hey, if this ever happens, fire an alert, let us know. And this is kind of, again, because it's a code talk, again, I'm totally happy to jump into this, but I'm going to get to some examples pretty soon. This is kind of what a plugin looks like. We call them domain model plugins. We've done this already for AWS and Azure. We're working on VMC and Google right now. But it basically lets you set and get secrets, create crons, so it'll go out and rediscover APIs if there's no eventing system. It'll expose an endpoint where you can point your fire hose at us. So for AWS, it's your CloudTrail events or CloudWatch events, and you can record metrics, send errors, and actually send notifications. All of this self-contained plugin that you hand us, and it'll all end up in your system. Yep.
So the refresh rate is based on the DMP cycle. The DMP controls how often you're going to go look and discover it and then report back up.
Correct. But we give you two ways to control that. So the question was, does the DMP control how often these alerts get sent and how often we go and discover things? And the answer is yes and no. Because the DMP gets two exposures to getting data. One is the cron, and that's for everything else that might not have an event stream. But we do give you the event stream as well. So in AWS, about 60% of the stuff works with CloudWatch events. And those the range is pretty varied. We actually have stats on it that I'm not ready to share, but I will at some point. But I've seen CloudWatch events take up to 4 hours to come to us. But in the majority, we're talking milliseconds to get to us. And so if it's the millisecond case, then we can alert you within less than 10 seconds on your Slack channel that somebody did something wrong, and here's the graph that shows that it's wrong, right? With event streams. Okay, so let me just take you through some of those examples that I just talked about. Hopefully, live demos, fun. So actually, this isn't even going to be a demo. It's like just showing you kind of the intricacies of Amazon. It does get really complicated because I like to point this out to people. There was a year, there's the internet at large gives awards out for API designs, and they give you for the best API design and the worst API design, and it, it's kind of a known thing. And there was one year where AWS won the best and they won the worst in two different services. So it almost seems like these groups don't talk to each other at all, and it makes it very difficult. So if you know what a security group is, it's effectively a firewall inside of AWS. It has 6 different names within AWS. Like if I say I'm talking about a security group, it could be called group, security group, VPC security group, RDS security group. It's kind of insane. So there is a lot of difficulty in actually mapping these things together and getting them into a model that's usable. So it was a lot of iteration, but we've got this part mostly solved. No bugs at all, promise. So I have a cheat sheet here. So this is kind of, again, code presentation. This is exactly what I just talked us all through, is how do we get a start building a plugin for Rosetta? How do we start getting these models in? And I'll take you through the S3 one. So if I do a list buckets on our dev account, right? This is our root API call. I call buckets like there's nothing above it. Maybe owner, but I'm going to leave that out for the conversation. So if I look through this, I'm like, okay, I have, I don't know, 110 buckets here that I want to all be part of a node. Great. So if I start looking at the actual API that exists for AWS, I can start looking through and I see that all these things exist about getting information about a specific bucket, right? All of these are just more API calls to populate either data, which is properties on the node, or new nodes themselves. And in general, what you want to do is opt for the node over the property because it gives you more flexibility in your path traversal inside the graph. Is everyone with me? Okay, cool. So if I start looking through this, I've realized now that I have to call a ton more APIs. Let's just look at one of them. So if we look at just a single bucket, all right, I know that this is going to become a node in my graph. Okay. Yeah, it's kind of small still, I guess. So this is going to become a node in my graph. It's also moved over. All right. What do we do with it? All right, let's just assume that's going to be a node. Let's go and get some more information about this thing. I'm going to go and get the actual permissions on it, right? So now I'm going to go and ask for the bucket ACL. And the bucket ACL is access control layer. So this is actually telling me what access various people have in it. But when I look at it, I come through and I say, all right, how would I model this? This one API call, to me, has given me an array of new nodes that I would call grantee, and another one that I'm going to call permission that I have to assign to this grantee. So this grantee has properties. This permission is another node. So grantee's a node. This is a node. Owner's a node. I'm going to actually go through and I'm going to say, okay, I'm going to create these as those sub objects. So now I've got this one API call has just given me 1, 2, 3 new types that are all hanging off of that S3 bucket, right? So it gets pretty big pretty quickly. If I go on and I do another. API call, just a same thing, same bucket, but now I'm going to go get the tags. Now I have a tag set. Well, what is that? That's a new node. So now I've got more nodes created on this thing, but it lets you start creating these very intricate traversal paths. So I can go through and I can say, give me any buckets that don't have tags on them, because it's a very simple calculation for a graph to do. Or I can say, give me any tag that doesn't have give me any buckets that don't have the correct tags on them. Even more interesting, right? More difficult to find. But being able to do that sort of thing in under 10 seconds is, you start to realize the power of the actual graph traversal. And then you can do some things too that are they have nothing on it. And so this is, what is that? I don't know. So there's a lot of issues, how is getting my bucket analytic configuration is truncated false. It makes no sense. So there's a lot of these things too, just to show you kind of the negative part of it. But anyway, so if I come back into my into an actual graph and I start asking for things, you can start to see some interesting things take place. So this is kind of it's like a hack area that we use. It does have our dev account information, or dev, not account information, but it's modeled our dev system. And if my laptop loads, oh, it's not too bad. So we can actually look into these things. Actually, let me, maybe I can just do that one bucket. I don't know if this worked or not. So if I come in here, this is the actual bucket we looked at, and you can see that we have various, we have a bucket here. You can see it's the type is a bucket. There's just a lot of this information on it that you saw from one of those returns. We come out here a little bit. You can see this is a bucket ACL, right? And it's got a lot of the stuff we saw in the ACL here. So that's mapped directly onto this guy. If we expand him out, you can see it has, you start getting, you can see this owner, right? Here's the display name, Paul plus dev. You can see up here, right, display name, Paul plus dev. And it just keeps going. It just keeps populating. There's the ACL grant. This is what we talked about here. Our grantee. It's got a whole bunch of grants. There's only one in this case. But I would expect it to be, here we go, the type bucket ACL grant, right? The full control permission that we saw. And it just keeps going, right? And so you can see that the power of this is, I don't care what the objects are. I care about the traversal through the graph. And that's what you would register with us as like the query. And we can notify you when any of these things happen. And the other cool thing is, if the path is non-explicit about the node itself, then what you'll return is all of the paths through or all of the paths that match that, right? So I only do have 5 minutes left, but I was going to show you kind of the craziness that ensues when you actually generate. I wrote a little thing to write out all the code that gets performed for AWS in a single region, and this is just listing just going through the SDK, finding the APIs, get, list, or describe, and then writing it all down. And it's, well, you can see 8,000 lines per region that we've got to go through. It's kind of funny. So thank God it's self-generating. But yeah, so this will run. We'll regenerate all of the code every time there's a new release of the AWS SDK. So it'll just regen, and go get all your new stuff. It's kind of funny because we know about features before they announce them, because the SDK is updated before the announcement comes out, which is kind of nice. And also not nice because it breaks. Quite often, actually. I've seen it. I've definitely seen it more than weekly a couple of times. But it's always backwards compatible. So I've never seen them break backwards compatibility, I should say, which is also nice. They're actually a good shop, obviously. They know what they're doing. So yeah, that's all the time I've got, guys, but I'm happy to field questions for a couple of minutes. Nothing? Okay. All right. Thanks, guys. How do I unshare?